Do aliens exist? Few questions have ever gripped humanity as tightly as this one. It's a question that sits at the intersection of science, philosophy, and pure curiosity. For centuries, we looked up at the night sky and wondered if we were alone. Today, for the first time in history, we're no longer just wondering. We're investigating. Because now we have the tools, and among all the targets in our search for life beyond Earth, one system stands out above the rest. A dim, distant star, surrounded by 7 rocky worlds. A system so compact, so unusual, and so promising that it has completely reshaped how scientists think about habitable planets. This is the TRAPPIST-1 system. And what we've recently discovered about it might change everything. Located about 40 light years away, TRAPPIST-1 is not the kind of star you'd expect to host life. It's small, barely larger than Jupiter. It's cool, emitting a faint reddish glow. And it belongs to a class of stars known as red dwarfs, the most common stars in the galaxy. In fact, the majority of stars in the Milky Way are red dwarfs. That alone makes them incredibly important. Because if life can exist around stars like these, then life might be far more common than we ever imagined. But there's a catch. Red dwarfs are complicated. On one hand, red dwarfs are incredibly long-lived. While our sun will burn out in about 10 billion years, red dwarfs can last for trillions. That's thousands of times longer. Plenty of time for life to emerge, evolve, and perhaps even become intelligent. But on the other hand, these stars can be violent. They unleash powerful stellar flares, bursts of radiation capable of stripping away planetary atmospheres. And because their habitable zones are so close to the star, any potentially life-supporting planet is right in the line of fire. That's the paradox. Red dwarfs offer time, but threaten survival. So where does TRAPPIST-1 fall in this spectrum? Surprisingly, it leans toward the hopeful side. In 2017, astronomers made a groundbreaking announcement. Using a network of telescopes, they had discovered not 1, not 2, but 7 Earth-sized planets orbiting TRAPPIST-1. 7. All rocky. All roughly similar in size to Earth. And most importantly, several of them sitting within the star's habitable zone. This was unprecedented. Never before had we found so many Earth-like planets in a single system. And suddenly, the question wasn't just, is there life out there? It became, could it be here? These planets are far too distant to photograph directly. So how do we know anything about them? The answer lies in a clever technique called transit photometry. When a planet passes in front of its star, it blocks a tiny fraction of the starlight. By measuring these dips in brightness, scientists can determine the planet's size, orbit, and even hints about its atmosphere. But that's just the beginning. With advanced instruments like the James Webb Space Telescope, we can go further. We can analyze the starlight that passes through a planet's atmosphere. And in doing so, we can detect the fingerprints of gases, oxygen, carbon dioxide, methane, water vapor, the building blocks of life. Let's take a journey through the TRAPPIST-1 system, starting from the inside and moving outward. The closest planet to the star completes an orbit in just 36 hours. It's fast. It's hot. And for a long time, scientists thought it might have a thick, Venus-like atmosphere. But new observations changed that. Instead of a dense atmosphere, TRAPPIST-1b appears to be a barren world. Its surface temperatures are extreme, and there's little evidence of any protective gaseous layer. In other words, this is not a place where life, as we know it, could survive. Slightly farther out, TRAPPIST-1c was once considered a promising candidate. It's similar in size to Earth and receives a substantial amount of stellar energy. But again, the data tells a disappointing story. There's little to no detectable atmosphere, no water vapor, no carbon dioxide, no signs of habitability. Another world seemingly lifeless. Now things start to get interesting. TRAPPIST-1d lies near the inner edge of the habitable zone. It's smaller than Earth with weaker gravity, but it receives just enough energy for liquid water to potentially exist. And here's the twist. We don't yet know if it has an atmosphere. Some data suggests it might. Some suggests it doesn't. There are even hints that it could be an ocean world, with vast amounts of water hidden beneath a thick atmosphere. If true, this could be a place where life might take hold. But right now, it remains a mystery. If there's one planet that has scientists truly excited, it's this one. TRAPPIST-1e sits right in the middle of the habitable zone. Its size is almost identical to Earth. Its density suggests a rocky composition. And most importantly, it may have an atmosphere, not a thick, crushing one like Venus, not a thin, fragile one like Mars, but something in between, possibly something Earth-like. This is huge, because if TRAPPIST-1e has a stable atmosphere, it could support liquid water on its surface. And where there is liquid water, there is potential for life. But life on TRAPPIST-1e wouldn't be like life on Earth, because this planet is likely tidally locked. One side always faces the star, bathed in constant daylight. The other side is locked in eternal darkness. Between them lies a narrow band called the Terminator Zone, a region of perpetual twilight. And this might be the most habitable place on the planet. Not too hot, not too cold, just right. A cosmic Goldilocks strip circling the planet. If life exists here, it might thrive in this thin ring between extremes. Moving further out, we find planets that may contain significant amounts of water. TRAPPIST-1f in particular is thought to be less dense than Earth, suggesting it could be rich in volatiles, possibly even covered in a global ocean. But there's a problem. At this distance, temperatures might be too low or atmospheric pressure too high for life as we know it. Some scientists believe these worlds could be steam planets, where water exists mostly as vapor. Others think they might be icy, or something in between. Again, the uncertainty is enormous. At the edge of the system lies TRAPPIST-1h cold, dimly lit, and likely covered in ice. It's the least promising candidate for life. But even here, scientists don't rule out possibilities like subsurface oceans, hidden beneath thick ice layers. After all, moons like Europa in our own solar system may host life in similar conditions. Despite all this potential, one major challenge remains. The star. Even though TRAPPIST-1 is calmer than many red dwarfs, it still produces frequent flares. And over time, these flares can erode atmospheres, strip away protection, and sterilize planetary surfaces. So the key question becomes, can any of these planets hold on to their atmospheres long enough for life to develop? On Earth, we're protected by a magnetic field. It deflects harmful solar radiation and preserves our atmosphere. If TRAPPIST-1e or any of its neighbors has a similar magnetic field, it could dramatically increase its chances of habitability. And there's reason to think it might. Tidal forces from the star could keep the planet's core active, generating a magnetic field through internal motion. If that's happening, it could be a game changer. Ironically, the same stellar flares that threaten life might also help create it. High-energy radiation can drive chemical reactions. It can help form complex organic molecules, even the building blocks of RNA. So while the environment is harsh, it might also be fertile. A cosmic contradiction. Destruction and creation intertwined. Right now, we're on the edge of discovery. We have hints, we have clues, but we don't yet have confirmation. Future telescopes, more powerful, more precise, will take this investigation further. They'll search for biosignatures, chemical imbalances that could only be explained by life. And when that moment comes, it will change everything. The TRAPPIST-1 system doesn't give us a final answer. Not yet. But it does something just as important. It shows us that Earth is not unique in its structure. That rocky, Earth-sized planets are common. That habitable zones are filled with possibilities. And that life might not be as rare as we once thought. Somewhere out there, on one of these distant worlds, under a dim red sun, something might be breathing, growing, evolving, or maybe not. Maybe they're all silent, frozen, barren, waiting. But the search continues, because for the first time in human history, we're close enough to find out. And when we finally do, the universe will never feel the same again.